There are two types of modern controllers. There are those that use analog components and process analog signals. There are those that use digital components and process digital signals. Both devices can handle analog or digital signals if they are converted prior to processing, converting digital to analog inputs for an analog controller and/or converting analog outputs to a digital signal, obviously vice versa for digital controllers. We will now look at analog and digital control systems. An analog signal has some feature which increases and decreases in the same way as the thing being transmitted. A temperature probe that changes resistance will allow for an electrical current to directly represent the temperature. When the temperature goes up, the current goes up. Live music is analog. Analog signals are often varying electrical currents. A digital signal has the original information converted to a string of bits before being transmitted. A temperature switch that closes when a certain temperature is reached will allow a voltage or lack of one to represent attainment of a temperature, a single bit signal. Digitally recorded and transmitted music is encoded into a digital signal and decoded and converted to analog at your headphones or speaker. Digital signals are often varying voltages. In an analog control system, the controller consists of traditional analog devices and circuits, that is, linear amplifiers. The first control systems were analog because it was the only available technology. In the analog control system, any change in either set point or feedback is sensed immediately, and the amplifiers adjust their output to the actuator accordingly. In a digital control system, the controller uses a digital circuit. In most cases, this circuit is actually a computer, usually a microprocessor or microcontroller based. The computer executes a program that repeats over and over. Each repetition is called an iteration or a scan. The program instructs the computer to read the set point and sensor data and then use these numbers to calculate the controller output, which is sent to the actuator. The program then loops back to the beginning and starts over again. The total time for one pass through the program may be less than 1 millisecond. This is normally quick enough, but not always. Sampling rate is a factor in systems with rapidly changing parameters. The digital system only looks at the inputs at a certain time in the scan and gives the updated output later. If an input changes just after the computer looked at it, that change will remain undetected until the next time through the scan. This is fundamentally different than an analog system, which is continuous and responds immediately to any changes. However, for most digital control systems, the scan time is so short compared with the response time to the process being controlled that, for all practical purposes, the controller response is instantaneous. The physical world is basically an analog place. Natural events take time to happen, and they usually move in a continuous fashion from one position to the next. Therefore, most control systems are controlling analog processes. This means that in many cases, the digital control system must first convert real-world analog input data into digital form before it can be used. Similarly, the output from the digital controller must be converted from digital form back into analog form. This slide shows a block diagram of a digital closed-loop control system. Notice the two additional blocks, the digital to analog converter, sometimes called a DAC or DAC, and the analog to digital converter, ADC. These devices, which convert data between the digital and analog formats, are discussed in Chapter 2. Also note that the feedback line is shown going directly into the controller. This emphasizes the fact that the computer, not a separate subtraction circuit, makes the comparison between the set point and the feedback signal. This is the end of our brief introduction to digital and analog controllers, which will be covered in more detail in Chapter 2.